Okay, good morning, everybody. So one of the prerequisites for this, before you can take this course, is that you've completed CISC 121. So the assumption is that you know how to do some Python programming. And so to show you, or to introduce you to the Java language, at least the basics of the Java language, it's, the way I'm going to do it is I'm going to show you how you do something in Python, and then show you how to do something in Java. And so for the basics, so things like using variables, writing an if statement, writing a loop, doing some arithmetic, and things like that. I'm just going to introduce the Python and then show you the equivalent to Java. Right? And so we're going to start out with Hello World, which is basically where we left off in the last class. So a Python program can be very short, right? It can be as short as a single line. And so you should know that a Python program starts running from the first line of the script. Right? So Hello World you can implement in Python just by using a print statement. Okay, so Java is a little bit more complicated, in part because it's an older language. And so in Java, if you want your program to run, you need to write what's called a main method. And if you want a method, you need what's called a class. Right? And so one of the criticisms of Java compared to Python is that in Java you have to write more stuff to do the same amount of work. Which is true in some respects. Right, so to do Hello World, you actually need to create a class. So here we've got our class up there. Right, and then we've got our main method there. And then finally, we've got our print statement, which is right there. Right, and so the thing shown in red is the part I want to focus on. I'm going to explain everything as we go along. So the thing shown in red, that's what you need to have a running Java program. Okay, so it always looks the same way. So it's always the words public, and then static, and then void, and then main, and then round brackets, and inside, it's either string ... args or string square brackets args. Right? Both are fine. They mean the exact same thing in this context. Okay, so that's difference number one, right? Just to write Hello World, you need at least 3 lines of code in Java. All right, so naming conventions are different in Java than they are in Python. So Python doesn't really have any fixed naming conventions. Java does have some fixed naming conventions. And so professional Java programmers have agreed on that the way you name things in a Java program should look the same way across all Java programs. So for example, when you name your class, right there, right, the name of the class should be in what's called upper camel case. So upper camel case just means that every word in the name is capitalized. Yeah, so every word in the name is capitalized. So if it's a single word name, you just capitalize the first letter. If it's a multi-word name, you capitalize the first letter of every word. Right? You're allowed to use underscores in the name, but you should it's generally agreed that you should avoid underscores except in unusual cases. You're allowed to use numbers in the name, but the first character of the name must be a letter. It's allowed to be the underscore as well, but really don't do that. So start with a letter, and then you can use letters, underscores, and numbers in the name. Okay, so a statement in Java corresponds to roughly a sentence in English. Right, and so a statement in a programming language can be run, and it produces some sort of result or effect. Right, so this isn't true in just Java. Many programming languages are described by statements. Okay, so many statements in Java end with a semicolon, and other kinds of statements in Java end in a block. So remember, a block is something that starts with a brace and ends with a brace. Right, and so here the print statement, right at the end, you can see ends with a semicolon. If you leave the semicolon off, the Java compiler considers that to be an error. So it's an incomplete statement. So the Java compiler will complain when you try to compile that program. Right? And we also saw that in the last class. Right? So unlike Python, where you don't have to end your lines with anything special, you must end most lines in Java with a semicolon. Okay, so strings in Python strings in Python can be single quoted with single quotes. You can use the double quote, or you can use a triple single quote, or you can use a triple double quote. Right? So there's actually a fourth form here that you can use where you have double quote, double quote, double quote, and then the string inside of that. Right? And so this is called a string literal, right? It's a string that you can write down. In Java, you don't, this is not true. So in Java, your only choice is to use a double quoted, your string literals must always be double quoted. You have no choice. Right? So I'm just going to flip over to Eclipse. Well, I'm going to try to flip over Eclipse because I'm holding a microphone. Hang on. Oh, sorry. This is, let me just fix this quickly. So I'm just going to put back hello world. Okay, so first of all, if we leave off the semicolon, so notice that in Eclipse, if you ever see anything red in Eclipse, there's something wrong. So if up there you can see there's a little red square, on this line you can see there's a little red mark, and on this line here you can see there's a very small red X. Right, so in Eclipse, if you ever see anything in red, there's something wrong with your program. And so here, if you hover over the error, it's trying to tell you that there's a syntax error, insert a semicolon to complete what's called a block statement. So you need your semicolon there. If you try to change your quotes to something else, so if you want to use single quotes, for example, right, again, Eclipse complains, right? So it's still red, it's underlined now, and if you hover over it, it says it's an invalid character constant. So the single quotes means something else in Java, and we'll get to the something else a little bit later on. Right, so double quote your string literals. It's your only choice. All right, so to print something in Python, it's very simple. And this is one of the really nice things about teaching new programmers Python. It's really easy to print something. So Python's print function, you just feed it a comma-separated list of stuff, and it prints the stuff with a space in between by default. Right? So if I wanted to print 2 plus 3 equals 5, right, there's lots of ways you can write this in Python. Right? One of the ways I'm showing you here, right? You just separate the, you can separate everything with commas if you like. You can make it all one string if you like, right? So that's kind of nice. In Java, again, you can't do that. So in Java, println, or the println method, accepts only one argument, and that argument must be a string. So let's go back to Eclipse very quickly. So in this version of println, right, we've got one string as the input to the, in this case, to the println method. If I try to feed it, if I try to do the same thing that I did in Python, so I wanted 2 strings, right, and I want to separate, and so I pass them into the method using a comma in between, right, you'll notice that now Eclipse it highlights println as being an error, right, and it says there is no version of println that takes in 2 strings, is what that error is trying to tell you, right. So if you want to print out multiple things using println, what you have to do is you have to join the strings together. And so the way you do that is with the plus operator in Java. And so if I use the plus sign between 2 things in Java, that means, sorry, 2 strings in Java, that means string concatenation, right? In other words, join the 2 strings together to produce a single string. Right. Now, if you run this, you don't get quite the right result. So when Java concatenates 2 strings together, it does not insert any special character in between the 2 strings. Right. So if you want the space there, you've got to put the space in yourself. Right. So I can insert the space in front of world, I can insert the space after hello, or you can put in your own space character. Sorry. Right. I can insert a, it's really hard to type with the microphone in my hand. Okay, so you can insert a double quoted space as well, right? So this also, so this now produces hello world with a space in between hello and world. Right, so println accepts only one argument. If you want to print out multiple arguments, you have to concatenate them together. Oh, sorry. Okay, now when you concatenate in Java, you don't have to concatenate just strings. So in this example here, I've got the number 2 concatenated with the string plus concatenated with a 3, and so on and so on and so forth. So the way that string concatenation works in Java is that you can concatenate anything you want to a string, but you have to be careful when you do this. And so in this particular example, it works. So when you read this expression here inside the brackets, right, it's something plus something plus something plus something plus something, right? And so you've got an expression that has a bunch of plus operators inside of it. And so when you try to figure out what this expression means, you have to, first of all, decide which operator has the highest precedence. In other words, which plus happens first, right? And so all the operators are the same, so they all have the same precedence. And so the rule in Java is if you have an expression involving multiple operators all having the same precedence, you work from left to right. So the way this actually gets evaluated in Java is it's a number plus a string, right? And so in Java, that produces a string, right? So anything plus a string or a string plus anything produces a string, right? So that produces a string, right? You now have a string plus a number, so that produces a string, right? So all of that is a string, plus a string is a string, plus a number, which is also a string. Right? Now the reason that's important is because if you change this expression a little bit, you get the wrong result. So for example, so I'm going to use a number plus a string, and we'll see what happens. So I'm just going to do 2 plus ABC, right? And we get the output we expect, right? We get 2 space ABC. Right, now suppose you wanted 4 plus ABC, but instead of 4, you write 2 plus 2. Sorry, this is actually going to work. I need to come up with an example where this is not going to work. Oh, suppose you wanted 22 plus ABC, right? And so instead of 22, you write 2 plus ABC, right? And so when you run this, you get 4 ABC. Right? And so why do you get 4 ABC? Well, it's because you go left to right. So 2 plus 2 is a number. It's 4. Right? And so now the number plus ABC is the string 4 space ABC. Right? So you have to be a little bit careful when you do this, right? To make sure you always get the right result when you want a string, make sure the first thing is a string. Right? So if I insert the empty string, so double quote, with no space in between is what's called the empty string, right? It's the string of length 0. It also exists in Python, so you can have an empty string in Python as well, right? But now when Java sees this expression, it sees a string plus 2, so it produces the string 2, right? And then it has the string 2 plus a 2, so that produces the string 22. I'm just going to say always do this, okay? And so now you get 22 plus ABC. Right, so you have to be a little bit careful when you're using string concatenation. Every once in a while, you might get the wrong result. The reason you're getting the wrong result is probably because you're not starting with a string to begin with. Okay, so when you, as soon as you start to make a non-trivial program, you're going to want to use a variable of some kind. And in Python, it's very easy, right? You just pick a variable name and you write the equal sign for the assignment operator. And then on the right-hand side, you put in whatever you want. So here we can write S gets the value hello world, S gets the value 123, S gets the list 1, 2, and 3. Right? And this is perfectly fine, right? So on the first line, S is a string, or S refers to a string. On the second line, S refers to an integer. And on the third line, S refers to a list containing the values 1, 2, and 3. This is perfectly fine in Python. Right? So in Python, the variables have no type associated with them. Right? You can store whatever you want in a Python variable. Right? This is really not true in Java. So in Java, Java is what's called a statically typed language. Whenever you have a variable, or whenever you want to use a variable, before you use the variable, you have to tell Java what type of value will the variable hold. Right? Once you've created the variable, you can use it to hold any value of that type, without having to say that it's, having to redeclare it. So in Java, the equivalent code would be to write string s equals equals the string hello world. Right? So this is variable declaration and initialization. right? I want this variable s. I want it to be the string hello world, right? So the first time I use s, I have to say that it's a big S string, and the capital is important here, right? It's capital S string. It's not lowercase s string, right? When I want an int, once I've used s, I can't change its type. So s is a string, and in this block of code, it's always a string. So if I want an int and I want to store it in a variable, I have to pick a different variable name. So on the next line, I have int t equals 1, 2, 3. Right? And again, I have to give a type to t before I use it. So the most commonly used integer type in Java is little I, int. Right? Again, the case is important. Right? Big I int does not exist in Java. And if you want a list, it's something even worse looking. Right? So in Java, if you want a list, you're going to write something like big L list, and then this angled brackets, and then inside I'm going to write integer, blah, 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 blah. So if this looks confusing, that's because it is. We'll get to this in week 5. Right? So don't worry about lists in Java for the time being. The syntax for them is a little bit awkward. Right? It gets a little bit worse. So if I want to make a list having the values 1, 2, 3, there's no easy way to do it. That's not entirely true. There is a way to do it, but the one way to do it is to make the list and then add the values 1, 2, and 3 to the list. Right? And so here I'm using a method called add to add the values 1 to a list, then add the value 2 to a list, then add the value 3 to a list. Right? Again, we're going to get to this probably in week 4 or 5 of the course. All right, so the important thing for now is when you want to use a variable, you have to give it a type. Right? Okay, there's something, where does this go? Okay, so we're going to come back to, are we coming back to this? Hang on, yes, we're going to come back to this shortly. Okay, oh yes, naming. All right, so when you name a variable in Java, there's also a naming convention for variables. So it's the same as for classes, except it uses what's called lower camel case. So lower camel case means the first letter always starts with the lowercase letter, right? And if you have a multi-word name, every the second, third, fourth, and so on word begins with an uppercase letter, right? So variable s is little s, not capital S. The variable t is little t, not capital T. The variable a list, well, that's a multi-word name, so the first letter of the name is a lowercase letter, right? And then the first letter of every word becomes an uppercase letter. So little a, big L list. Right? And so that's the convention that Java programmers have decided should be used in a Java program. Now, Eclipse doesn't care. So hang on, let me show you this. Okay, so here we've got two variables, s and another s. Right? So I've named them according to Java's naming convention. Right? I'm using lower camel case for the s, and I'm using lower camel case for another s. Right? So everything's fine. Now Java doesn't care how you name these. Right? As long as it starts with the letter, Java's perfectly happy with the compiler's perfectly happy with this. So I could call this big S A, and I could call this big A another s. Right? And so this breaks one of the style conventions that Java programmers have agreed on. Right? You should not name your variables this way. The reason you shouldn't name your variable this way is because Java programmers are expecting something else to look like this. Right? Namely, they're expecting classes to look like this. Right? And so when an experienced Java programmer looks at this, they're saying, well, there's something weird going on here. Right? It looks like there's a class another s here, which it would not be legal in Java anyway. But it's confusing to people who work in Java a lot. So make sure to use lower camel case. All right, what about comments in a program? So in Python, Python only has one form of commenting, right? So it's the hashtag or the pound sign. And so Python's comment is what's called a line-ending comment. Right? So if I start with a comment at the beginning of the line, the entire line is a comment. Right? At the end of a line, I can also add a comment. Right? But in Python, you can't insert a comment somewhere in the middle of the line. There's no way to do it. Right? You might have been told in your first course that a triple quoted string is, that has no variable is also a comment. That's not true. It's still a triple quoted string. You may not have been told that either. That's fine. It is a not uncommon belief that a triple quoted string is in fact a comment in Python. That's not true. So Java has an equivalent comment to the hashtag in Python. So the equivalent comment is the double /. And so Java inherits this from the C programming language. Right? So double / is your line ending comment in Java. Oh, I guess there's some other stuff here I should explain. So if you want a floating point number, so a number with a decimal point in it, then normally what you choose is the type double. Right? So here we're computing, this is just the formula for compound interest. If you don't know what it is, don't worry about it, it's not important. Right? But I'm calculating something with what looks like real numbers. So if you want, if your application is using something that looks like real numbers, in other words, the numbers have decimals in them, in Java you typically pick double. The operators are mostly the same. So if you want division, well, it's just the /, right? And that's true in Python as well. So plus, multiplication, addition, they all work the same way. Python has a exponentiation operator, right? So double star is 1 + r raised to the power 10. Right? Java does not have an exponentiation operator. Right? Again, this is because largely because it inherits its syntax from C, which also doesn't have an exponentiation operator. If you want to compute something raised to another power, you have to call a method in Java. And so if you want to raise something to an exponent, you have to write math.pow, round brackets, right? And then you pass it two arguments. The first argument is the base, so 1 + r. The second argument is the exponent. So math.pow, 1 + r, 10, computes 1 + r raised to the power 10. Java also has a multi-line comment, or a, so a multi-line comment. So a multi-line comment in Java starts with /* and ends at the next */. So you have to be careful with this. You can't put a comment inside of you can't put a multi-line comment inside of a multi-line comment. It won't work. Because Java considers the first */ to indicate the end of the comment. And so if I want to split my comment across two lines, I can write /* and then the comment */. Right? Now, occasionally what's useful is to insert a comment somewhere in the middle of a line. And so if you want to do that, that's where the multi-line comment comes in handy. Right? I can insert a comment into the middle of an expression in this case. Right? So /*, hey, I can put a comment here, //, and the rest of the expression follows on the next line, or even after the comment. Right? So there's two forms of commenting in Java. Again, no exponentiation operator in Java. If you want to compute the exponent, you have to use math.pow instead. Okay, so in Python, there are, so whether you know this or not, Python provides the programmer with the illusion that there are different types of values. Right? So for example, you have logical values, right? True, false values. So you know that there's a big T true and there's a big F false. You know that there are things that look like integers. So 1, for example, with no decimal, it looks like an integer. 1.0 looks like a real number. In Python, that's called a float. A string is called, oops, sorry, this is actually wrong. A string in Python is actually, its type is actually str. And a list in Java, its type is list. And if you want to know what the type of something is in Python, there's actually a function that tells you. So there's my Python. There's this is what the heck is this? This is the Python interpreter in Windows. Right. So if you want to know what the type of something is, you just use the function type. So type 1 says class int. Right. So this indicates that the type of 1 is an int. As soon as you put a decimal into the value, it becomes float. Right. Right. A string is str, as you'll see right there, right? And a list, this should say, oh, sorry, It's in quotes, which is incorrect. There we go. Right, and so that's a list. Right? So Python does, in fact, seem to have types, whether you know it or not. Right? Okay, so in Java, the corresponding types and literals are as follows. So if you want something that's true-false in Java, that's a little b Boolean. Somewhat confusingly, if you're coming from Python, the constants are little t true and little f false. Right? And this is because of Java's naming convention. Right? So classes begin with an uppercase letter. Right? And so the word true is not a class. Right? It's a Boolean literal. So Java uses lowercase t and lowercase f for true and false. Right? For an int, you usually reach for int, but it turns out there's other things you could use. Mostly not important for the purposes of this course. Right. If you want a floating point value, the usual type you reach for is little d double. Strings we've seen are big S string. Lists we've also seen are big L list. But I would recommend for now, if you haven't programmed in Java before, just ignore lists for the time being. Notice on the right-hand side, things look a little bit different than on the left-hand side. Okay. So in Python, so did they tell you what a reference was in 121? Nod yes or no. Or nod yes or shake your head no. Okay, so this is not good. So in Python, everything is in fact a reference to an object, right? So so I guess in 121 we tell you that you're going to learn procedural programming, but in fact Python is an object-oriented programming language, and everything in the language is in fact an object. Including functions and other stuff that you wouldn't think might be objects. So when you write something like x equals 1 in Python, that 1 is not really the integer number 1. It's something else. And so we say it's a reference to an object, and I'll explain what that means in just a moment. Now Java also has these things called references. Right? So Java has reference types. Right? Anything that begins with an uppercase letter is probably a reference type in Java. Right? So big S string is a reference type. Right? Big L list, reference type. Big A array list, also a reference type. Yet another reason why you should not name your variables with an uppercase letter. Right? Okay, so classes are what are called user-defined reference types. Right? So when you make a class like hello world, right, you give it the name big H hello, big DW world. Right? And that's because when you make a class, you are creating your own type. Right? So when you make the hello world program, you've created the type big H hello world. And so that's why Java programmers have decided that you should always name your classes with an uppercase letter. Right? It's because it defines a reference type. Now, this is the confusing part in Java. Well, it's probably confusing in Python as well. Java also has primitive types. Python does not. Right? So a primitive type in Java, if it's a type, it begins with a lowercase letter. Right? So little I int, little d double. Right? Now, if you want to confuse people, you can make a class and name it with a lowercase letter. And then Java programmers will think, hey, that's a primitive type, when in fact it's not. Right? Most experienced Java programmers will recognize it's an error right away because they know what the primitive types are in Java. All right, so there's 8 primitive types in Java. We're only interested in 4 of them, mostly. 4 or 5. Right? So Boolean is important, obviously, because it represents true and false. Right? Int is the normal type you use for integer values. Right? Long is just like int, except it can hold bigger values, and I'll explain what that means in just a second. Char we also need. So the individual characters in a string, they're all of type char, which is another difference compared to Python. And if you want a number that represents a real value, you typically use double in Java. Right? But float also exists. All right, so what the heck is a reference type? So a reference type, or a reference variable stores a reference to an object. Right? And in Python, all variables are reference type. So when you write x equals 1, right, the value of x is not 1. In fact, the value of x is something that refers to an object whose value is 1. Right? When you write y equals 1.0, the value of y is in fact not 1.0. The value of y is something that points to an object whose value happens to be 1.0. right? And when you write s equals the string hello, s does not in fact store the string hello, right? S stores a value that gets you to an object whose value happens to be hello. Okay, so to explain all of this, I'm going to use what's called a memory diagram. And so these memory diagrams appear in many different forms. So this is just the one I happen to use in 124. So in memory diagram, so basically I'm going to give you a very primitive model of computer memory. Right? So this is not really an accurate model. This is a very primitive model. So this is just a way of thinking about reference types and primitive types. And so what I'm going to try to do is draw a picture of computer memory. And so all that we're going to use is a table. It has 3 columns. Right? Your first column, you can put in a variable name on any row. Right? So in each row, you get to use one variable name. Right? On each row, every row gets assigned a unique non-zero integer value, which is what's called its address. Right? If you want to think of this as just a big list, that's fine. Right? So this is just a list. The first element has index, the first row has index 0, the next row has index 1, the next row has index 2, and so on and so on and so forth. Right? The actual number that's here doesn't really matter. So if you want to draw your picture starting at address 5000, that's fine with me. Right? The number here is not important. What's important, though, is that the addresses are unique. And that there's only one address per line. Right? And finally, on each row, you can store exactly one value. Right? What values can you store? Well, I can store true, false. Right? I can store any number, so an integer or a double value, so a real value. Or I can store a memory address. So I can store one of these as the value as well. Right? So I can store true, false, I can store a number, or I can store a memory address. Okay, so in Python, if you were to draw the memory diagram of the code that I just showed you, you would get the following. Right? So on row 1, we have the variable x. Right? The address of x is 0. Right? Now, what is the value stored in x? It's not 1. Right? So remember, we wrote x equals 1. The value that's stored here is not the number 1. Right? Instead, it's the address of something. Right? And so here I've written A104. Right? The A simply means it's an address. Right? Because otherwise, if I just wrote 104, you can't tell if that's the integer 104 or if it's an address 104. So I'm just going to write big A, 104. And that means that you want to go to memory address 104 and see what's there. Right? And so when you go and look what's there, that's where your int object actually is. Right? And inside that int object, there's some information that says, hey, this thing is an int and its value is 1. Right? So underneath the int object, I don't have any information. I don't actually know what's there because I don't know how Python implements this. Right? But after somewhere in this memory here, there is the information about that int. Right? Its value is 1, it's an int, and so probably a bunch of other stuff as well. When you write y equals 1.0, well, you get a variable y, right? And you don't store the value 1.0 beside y. Instead, you store a reference, right? So the memory address is a reference to a float object, right? And inside that float object, there's some information about its value, namely it's 1.0, right? And finally, when you write s equals hello, right? You don't store the letters hello here. You store the address of some object, right? Which is down here. And inside this object, there is a bunch of memory here. And inside that memory, there's probably the letters H, E, L, L, and O. Exactly how it's stored, we don't care. It's not important for our purposes. Right? But this is what we mean when we say that variables in Python store references to objects. Right? You can think of them as storing the address of the objects. Right? They don't store the objects themselves. Right? And even things that look simple, like ints and integers and real values, are in fact not simple in Python. Right? They actually correspond to objects which live somewhere else in memory. Okay, any questions about that? Yes?
Just curious, if you set a variable, go to another variable,
yes.
Is the value of the memory address of the other variable or of the value of the other variable?
Right, so you're asking an important question. So the question was, what happens when you write the following? So if I write, so I have x and y. So what happens if I write z equals x, right? And so in Python and in Java, the equals operator is the assignment operator, right? And so what that means in both languages is you take the value of the left right-hand side. So you take the value of x, and you store that value in z. So when you go over to your memory diagram, right? Sorry, z, right? So I have a value z. I don't care about the memory address. It's not 0, 1, 2, 104, 238, or 998, right? So when I write z equals x, you take the value of x. So the value of x is A104, and I store that on this line. So it's now A104, right? And so when you write z equals x, sorry, what did I write? Z equals x or z equals y? X? Okay, so if z equals x, then I wrote the right thing, right? So you store the reference beside z, right? And so now you have x and z, right? X points to the address at, x prints to the object at address 104, right? Z points to the same object, right? And so x and z both refer to the same int object in this case, right? Whose value is 1, right? Now the interesting thing in Python is you can't change the state of this object, right? So once you make the integer 1, you've got an object, its value is 1, and there's no way to change its value, right? So when you write x equals 2, what ends up happening is you get a new object whose value is 2, and now x refers to the 2, right? So if we wrote x equals 2, what ends up happening is, right, this value now changes. So I'm going to change it to 1099, right? And at address 1099, there would be a new int object whose value is 2, right? Notice that z still refers to the old int object whose value was 1, right? And so that's what assignment means in, when you use the assignment operator, that's actually what's happening, right? It's the value of the variable gets assigned to the other variable. So in Python, a reference gets assigned to another reference. Any other questions? If that's all confusing, that's probably why they don't explain that to you in 121, right? Or 101. So all you have to remember, though, is that in Python, whenever you write, whenever you're using some value, it's actually a reference to an object somewhere. Okay, so what is the difference between a primitive type and a reference type? So the difference is a primitive type actually stores the value of the primitive type of the primitive value. Right? It doesn't store a reference. Right? So in Java, when you write int x equals 1, x really stores the value 1. When you write double y equals 1.0, y really stores the value 1.0. Now, when you use a reference, it's the exact same as what happens in Python, right? So when you write string s equals hello, s stores a reference to a string object whose value happens to be hello. So the memory diagram in Java looks like this, right? So x stores the value 1, right? Y stores the value 1.0. S stores a reference to a string object at address 135, right? Inside the object, there's some stuff that that probably encodes the characters H, E, L, L, and O, right? Right, and so that's the difference between a primitive value and a reference type. So you might ask, why are the languages different, right? So why does Python do it one way and why does Java do it another way, right? And so there are advantages and disadvantages to both approaches, right? So in Java, by storing the value 1.0 here, so number one, you save some memory, right? So I don't have to make an object whose value is 1, right? When I access that value, right, I can just look at the value here. I don't have to jump somewhere in memory and grab that value, right? But there's a problem, right? There is a consequence to this, right? The value that you can store here, you have to remember this actually corresponds to physical computer memory. So if you're storing a value somewhere in memory, you've got a limited number of bits, or you have a limited amount of space in which to store that value, right? And so that means that for an int or a float or a double, right, there is a finite range of values that you can store in Java, right? If I only have a finite number of bits or a finite amount of space here, right, I can only write so many digits here before I run out of space, right? That's not true in Python. So in Python, if you have an int, right, it actually corresponds to an object, right? And that object can allocate as much memory as it needs to store the digits of that number. So you can have arbitrarily large ints in Python, whereas that's not true in Java. Right. Okay, so all of the primitive types occupy a predefined fixed amount of memory. So the Java language says an int shall occupy 32 bits, and that's all you get, right? 32 ones and zeros. The different primitive types occupy different amounts of memory, right? And so, of course, there's an immediate set of implications of all of this, right? So in Java, your primitive types represent a finite number of values, right? So in other words, there is some smallest int value that you can represent, and there is some largest int value that you can represent, and you cannot represent any value outside that range with an int. Right? So when you're using integers, when you're working with integers normally, or at least for most routine programming tasks, you're going to reach for int. Right? So if you want to know what the maximum value of an int is and the minimum value of an int, so the minimum means the most negative value, right? Then it turns out those constants are stored in a class. Right? So they're stored in the class big I integer. Right? If you want to access those values, you write big I integer dot min value all in caps. Right? And so if you see anything in all caps in Java, that probably indicates that you're using a constant of some kind. So that's another naming convention that Java uses. Right? If you want a constant value, you're probably naming it in all caps. So big I integer dot min value with an underscore between the min and the value is the most negative value that you can store as an int. Right? And that's roughly minus 2 billion. Right? Similarly, big I integer dot max value is the largest integer int value you can store. Right? And again, that's roughly 2 billion. Don't memorize the exact value. It's not important in this course. Right? Okay, so if you write down a number in Java, and there's no decimal point in it, then Java probably considers that to be an int. Right, so that's what's called an int literal. Right, so any number written without using a decimal and not ending in L is an int literal. Right? If it ends in an L, then it's a long literal. So long is exactly the same as int, except it can hold a much wider range of values. Right? So a long in Java is 64 bits long. Right? So it can hold a much wider range of values than int. If you want to write down a long literal, it's an int it's an integer value followed by an L. Okay, so if you try to write down an int literal that's bigger than you can store in an int, it's a compile time error. So let me just show you that quickly. Okay, so we know that the largest int is roughly 2 billion. So int x equals, so I'm going to use 3 billion. And I'll also show you that you can use the underscore. Okay, so if you're writing long sequences of numbers, it's often convenient to separate every 3 digits with something, right? In North America, you'd probably use a comma, but in Java, you can use the underscore in an int literal to separate the digits. Right, so here I've got the number 3 billion. I know that that's greater than integer max value. And so if you hover over this, it complains, right? It says the literal 3 billion of type int is out of range, right? So you're not allowed to do this. So the compiler is smart enough to know that if you try to store a value that doesn't fit an int, it's an error. Right? Change that to 2 and everything's fine. Right? Notice the error goes away. Okay, so if you want to do operations with int, well, you have the usual set of arithmetic operations. Right? You get parentheses to force precedence. Right? Anything inside parentheses gets highest precedence. You get the negative sign, so you have signed integer values. Right? Addition, subtraction, multiplication, division. And there's also remainder that we'll talk about a little bit later on. If you know what binary, octal, and hexadecimal are, there are ways to write those in Java, but they're not important for the purposes of this course, but you can do it. Right? So there is another funny rule in Java that is different than in Python. So in Python, if you write something like 1 divided by 2, right? So an int divided by an int, you get back a float. Right, you get back 0.5. That is not true in Java. So in Java, if you perform an arithmetic operation involving 2 int values, the language says you always get back an int value. Right? So what happens with division? So if I do 1 divided by 2, what the heck do you get? Right? So in Java, division is what's called truncating division. right? You compute the quotient, and then you throw away everything after the decimal point, right? So do the division, toss away everything after the decimal. So here we have 1, 3, and 13, right? If I add 1 and 3, obviously the answer is 4, right? If I subtract 1 and 3, I get minus 2, right? If I divide x and y, so if I divide x by y, so 1 divided by 3 is 0.33333. So you throw away the 0.33333 and you get 0. Right? If I do z divided by y, well, that's 13 divided by 3, so that's 4 and a bit. So throw away the and a bit and you get 4. Right? The same is true if you have negative values. Right? So negative 13 divided by 3 is minus 4 and a bit. So throw away the and a bit and you get minus 4. Right? You can use parentheses to force precedence. Right? So here we're going to compute x plus y plus z and then divide by 3. Right? Without the parentheses, you do z divided by 3 first. Right? Bedmas. And then you add the x and the y. Right? So x plus y plus z is 16, 17 divided by 3, 5 and a bit. So throw away and the bit to get 5. Okay, so this is going to, I guarantee that this is going to get some of you, right? So you're going to do things like compute the average of a bunch of values, of a bunch of integer values, right? So you're going to sum all the integer values, and then you're going to divide by the number of integer values, right? So that means you're going to take an int and divide it by an int, and that's going to give you back an int, when you probably want to do it as when you probably want a real number instead. Right? So be careful when you're doing this. Integer arithmetic in Java always produces another int. Okay, so, sorry, I just want to check the time. All right, so just very quickly, if the rule is I do some operation with 2 ints and I get an int, right? What happens when the result doesn't fit inside the range of int? And so what happens is you don't get an error, and this is a bit of a problem, right? There's no error. Nobody tells you anything that there's a problem, right? Instead, what happens is you get what's called wraparound. So if I start out with the largest integer value, right? So 2 billion and something, right? Remember, that's the largest value that I can store in an int, right? What happens if I add 1 to it, right? I don't get an error. I don't get a warning. I don't get anything, right? I get a result, right? And the result is integer min value. So what happens is when you start with the largest value and add 1 to it, you wrap around to the other side, and now you have the smallest int value, right? So I start with the largest int value and add 2, so over here, right? I add 1, so I get integer max min value, and then add 1 more. So that's integer min value plus 1, right? And so on, and so on, and so on. The same is true with multiplication. So if you multiply 2 values, right, you wrap around the one end and you go back to the other end, right, and you keep on going. So it's as if the range of values was cyclic in Java, right? And this is the way that many programming languages work, right? So C works this way, C++ works this way, and many other languages work this way as well. Right. Python doesn't work this way, right? So Python, because everything's an object, right, there's no upper bound on the value of an int. So it can simply increase the amount of memory that it needs to hold the extra digits. All right, I think this is a good place to stop because I'm also out of time, and we'll continue this discussion tomorrow.